Okay, hi guys. We're on the process of coming live right now. I'm here with seventh period. Say hi, seventh period. Hi. Oh, the two sound so happy to be here. We're going to do the review for the performance final. So it looks like the paper that you have on the screen. The performance final is very heavy with probability. You will have your probability test first. My understanding is those questions are all multiple choice, and then you'll have the performance final. So the other questions to prepare for the performance final, I've embedded in those trifold packets, but this I kept it's all about probability. So let's take a look at the first question. A reporter asked 50 voters if they plan to vote for a new library and a new arena. The table shows the results. The first thing that you should do when you see these types of tables is to just add all the numbers to get our totals. So here I'm going to put a T for total. I'm going to put here a T for total. If I add going cross, 21 plus 30 is going to give me 51. 57 plus 42 is going to give me 99. When I add down, I've got 78 and I've got 72. So I can add those together and I can see that there really was 150. Like that makes sense. The table is right. Coming up for question 2, you're going to actually be creating your own table. So that's one way to check that you did the math correctly. Okay, now let's take a look at the questions. We love asking kids things that have the word given. Anytime you say given, it's going to narrow down that field. So right here, I have choice or question A, given that a voter plans to vote no for the library. So because it says given that happens, we don't care about any other numbers. The only numbers we care about are the numbers for people who voted no for the library. So I'm going to put a green box around here. So I know that those are the only numbers I care about. I don't care that there were 150 voters because 150 voters did not vote no for the library. I only care about these 72 voters who did. So it says, given that a voter plans to vote no for the library, hint, anytime you hear a given piece, that number is always going to be your denominator. So given that a voter plans to vote no for the, well, if you have a two-way frequency table, that number will always be your denominator. So here, I know my number is going to be 72 because there were 72 people who voted no for the library. Then it says, what was the probability that they will also vote no for the arena? So I only care about what's in that green box. Here's arena, here's no. So I know it's going to be 42 over 72. Speaking, what we do is we have you turn those into decimals. So 42 divided by 72 will give you 0.58. Now you also, someone had mentioned that they didn't remember how to do percentages. All you do is multiply by 100. So if you think about 58 cents, that's 58% of $1. This would be 58%. So the next question is kind of tricky because the next question does not have the word given in it. It still talks about what's the percent of voters that plan to vote no for both the library and the arena. Now, because, I shouldn't have done that. This is 0.58. Because it says there's nothing with given, I do care about everyone. So I know altogether that there's 150 voters. So my denominator is going to be 150 because I'm talking about everyone. It didn't say given something happened. It says because of all those voters. So now it says voted no for both the arena. Here's no arena and here's no library. So 42 people voted no for both. So I'm going to have 42 divided by 150. And that'll give me, I think it's 0.28. Yep. So 0.28 is going to be my numbers there. Now notice, both things talked about no library and no arena, both A and B. The difference is A, it only cared about people who also started off by voting no for the library. It eliminated everyone else. B, it looked at everyone all together. Okay, let's take a look for C. Switch this. C and D, it says, given for C that the voter plans to vote yes for the arena. So I'm going to look at arena, and because it says the word given, I know the only thing I'm looking at are these numbers. And when we added that up, that was 51 people. So I know because this is a two-way frequency table and because it said given, that 51 is going to be my denominator, 51. And it says, what is the probability they will vote no for the library? So now I'm looking, okay, here's no library. So it would be 30 divided by 51. Which is, yep, 0.588. Okay. So, or 0.59, which is fine. What is the probability that a randomly selected voter will vote yes for a new library, given that they vote yes for a new arena? See how they tricked you and they moved the given at the end? So now we're still only looking for people who voted yes for the arena, which is the same we had before. Why am I not writing? Oh, because I'm erasing. Yes for the arena, and that they vote yes for the library. So we're going to have 21 out of 51. And then someone do that one for me already? 0.41. Well, I can't get rid of that, so I'll just do it like this, 0.41. Okay. And it kind of makes sense, right? Because this says yes for the arena here. This says yes for the arena here. Both of those were given. And look at when you add 0.59 and 0.41, you get 1. You get everyone. So that makes sense. Questions in the class? We're good on those? Thumbs up. Cool. Let's go on to the next one. This one is kind of tricky. Here we're going to make your own two-way frequency table. And I honestly had to do this twice because I screwed it up the first time. So the first thing that we're going to do is read the question, and we're going to look and highlight the important information. The owner of Pappy's Perfect Pizza wants to know which one of his locations has a better record for on-time deliveries. So we know things are either going to be on time or the opposite of on time. I'm just going to write late. He collects data for 250 deliveries. His downtown location has 75 out of 132. And his midtown has 69 out of 118. So I'm just going to go ahead and I'm going to write downtown here. And I'm going to write midtown here. Which, oh, there it goes. Then I know that they are either on time or they could be late. Now, I left a little space because remember, we like to put our totals in. So these other columns are for me to write my totals. All right, now I can fill it in. So I've got how many people did 75 were on time for downtown. So I'm going to go to downtown on time was 75, and their total was 132. Midtown had 69 on-time deliveries out of 118. But then I'm just going to do plain old subtraction to get my missing number. So this will be 57 here. And, whoops, I definitely did that one wrong. Minus 49 here. And then good practice, even though you're not required to do it, is make sure you have all the totals done. So I'm going to add these other numbers up also. So this is 144. And if we see when we did it, 144 plus 106 equals 250, and 132 plus 118 equals 250. So we know we did our table correctly. Yay, us. Okay, so what is the probability that a delivery made by the downtown staff is late? Now, this is where it's tricky. It doesn't say the word given, but we only care about the downtown staff. So even though the word given is not there, we're going to believe that it's there. So there are 132 deliveries from downtown, so that's my denominator. Of the late, there were 57. So my answer is 57 divided by 132. Am I going too fast? We good? Okay. Then it says, can you conclude that a pizza being delivered by the downtown location and being late are independent events? So this is when we're going to have to jump over to our formula sheet, which I don't have up immediately, so let's go to it. On the Georgia geometry formula sheet, it literally has the words independent events. Okay, and I'm going to leave this stuff up so that we can see it. So down here, it says the multiplication rule for independent events is if the probability of both things happening equals the probability of A happening times the probability of B happening. It's down here with all that kind of stuff. So let's go back to our document. So now let's take a look. Can you conclude that a pizza being delivered by downtown location and being later independent? So we know that this given statement, we know it's 0.43. That's like what we pulled from the table. But what we can do also is we can also say what's the probability that someone was downtown. Pen tool, Michelle. All right, I'm going to move. I'm going to run out of space. Let's see. Need to have space to write. Okay, so here I'm going to take downtown location. Well, the probability of something being downtown is 132 divided by 250. Okay. And we get that because out of 250 deliveries, 132 of them came from downtown. Then we're going to look at how many of all the deliveries were late. Well, we have 106 out of 250 were late. So what we're going to do is we're going to multiply. Let me switch colors over here. We're going to multiply 132 over 250 times 106 over 250. And we're going to see what we get. If we get 0.43, then we know that they're independent. If we don't get that, then we know that they're dependent. So we multiply this together, we get a huge number. We get 13,992 divided by 62,500. We do 13,992 divided by 62,500. We get 0.22. So because 0.43 and 0.22 are different numbers, then we can conclude that they are actually dependent because the numbers are different.